You tap a glowing circle on a glass screen, and less than a second later, a tire hits the pavement. We expect urban mobility to be frictionless. You open the app, grab the bike, and go. But managing a fleet of scattered physical assets used to be a logistical nightmare. City administrators and transit operators constantly battled lost inventory, broken locks, and disjointed schedules that left commuters stranded. The primary point of failure sits in the gap between a digital command and a real-world result. Pressing a button on a server in California doesn't automatically turn a physical gear in New York. There is a vacuum between digital intent and physical action. Bridging that gap requires a constant, bidirectional flow of data between the server and the street. Standalone websites are unable to span this distance. They lack the reactivity needed to manage assets in motion. Historically, web development treated the internet as a destination, a screen you simply looked at. Today, the code has to reach out and control the physical environment, demanding a synchronized hybrid infrastructure. Making a smart city commute feel effortless takes an immense amount of effort. It requires mastering back-end code, clean user interfaces, and street-level hardware, all operating together as a single, unified organism. Let's step inside the technology workspace where this ecosystem is built. Long before a commuter ever pedals down a bike lane, their journey begins as a cascade of raw back-end data. At the bottom layer, raw data streams flood upward into a central processing node. But raw database output creates an intimidating bottleneck. A clean UI/UX interface must slide into place as a translation layer, smoothing the chaotic data into clear upward pathways. Thousands of lines of location logic and security protocols are deliberately distilled down into simple visual cues, giving the user a clean map and a single button that simply says unlock. A clean interface performs a vital function. It allows a person with no coding knowledge to command a massive, complex back-end architecture. Once the user taps that polished screen, the signal leaves the digital realm. Now it has to hit the street and generate real-world momentum. This wireframe model shows the bicycle rigged with IoT sensors. Notice the communication nodes on the wheels, lock, and handlebars. As the bike moves, these sensors do the heavy lifting, emitting a constant data stream to the cloud to verify GPS, fare, and brake safety. Multiply that constant stream by 5,000 bicycles operating simultaneously across a grid, and you generate a massive, instantaneous data feedback loop. To manage this massive influx of information, the operating team relies on a centralized software dashboard that aggregates every single pulse coming from the street. Through that dashboard, they monitor growth, track upward trends in ridership, map out neighborhoods with high demand, and locate areas low on vehicles. When anomalies occur, a cluster of bikes with drained batteries, or a localized GPS glitch, a collaborative human team spots it immediately and dispatches technicians to optimize the fleet. A functioning smart bike network is never a finished product. It operates as an endless conversation. The street constantly generates data, and the command center responds, optimizing the flow minute by minute. We have traced the complete path, starting from the microscopic logic of a back-end server, through the translation of an app interface, all the way out to the macroscopic management of a city-wide fleet. Building this requires a skill set that breaks traditional industry boundaries. A standalone web design agency cannot build it, and a strictly back-end software firm cannot maintain it. The modern tech companies executing this are holistic architects of urban mobility. They engineer complete environments where the software, web design, and physical hardware are built to lock together. When that environment functions properly, a city's rhythm improves. Commuting times drop, transit gaps are filled, and the daily friction of getting from point A to point B disappears. So when a high-tech bicycle stands quietly on a corner at golden hour, ready to unlock at the exact second a commuter needs it, that successful ride is the tangible result of a complex stack operating invisibly in the background.